All right, 215 is the new thing we're on, compound Boolean expressions. So here's the learning objective: represent branching and logical processes by using nested conditional statements. So we're going to have ifs inside of ifs, and evaluate compound expressions in code. So that's the ands and ors and nots. So right here it says nested if statements consist of if statements within if statements. We've already done a practice problem that had if statements and if statements before. Logical operators, you can have a not for the exclamation point and for double ampersand, and the two absolute value bars, I guess, for the or. And make sure you understand what each of those mean. I don't think it's on the Java quick reference, so you have to know those. It says an expression involving logical operators evaluates to a Boolean value. So just like before, it's either outputs a true or false based on those operators. And then it says when the result of a logical expression using and or can be determined by evaluating only the first Boolean operator, the second one is not evaluated. So it's short-circuited. Okay. This is something that's often ignored with programming because it's not important at all, but it's on the test. And I'll go into more specifics about how that works in a little bit. But first, what I want to do is go over this and or stuff. This is just called the truth table. And one way of looking at it is you have the inputs here. So this and this are going to be the inputs, and then this is going to be the output here. Okay. And I'm going to have input 1 and input 2. Okay. This particular output is going to involve, let's just do ands. Okay. Excuse me. The way an and works is they both have to be true for it to be true. So, for example, if I did something like true and true, that would be true because they're both true. It involves both of them. So and is not, one or the other. It's both. They have to both be true. So if you had something like true, false, what would this output to? False. Very good. Okay. False, true would be false. But this is where it gets tricky. What's false, false? No, it's false. Okay. They're both false. The main thing with and is they both have to be true to output a true. Okay. Now, if I did this for the or, it's going to be slightly different. I'm lazy on this. And again, we're thinking like computers here, so start thinking what the possible answers can be if I was doing ors. Okay. Now with ors, it could be one or the other, or it could be both. Okay, there is a such thing as an exclusive or, where it's either one or the other thing. But an or in just a plain or, not an XOR, it's called, for an exclusive or. It can be one or the other or both. Okay, so true or true would be what, people? True. True or true is true. Okay, what about true or false? True. What about false or true? True. And then what about false or false? False. Okay. So kind of notice the difference between those two. Okay. And the other thing that you should also know about too is if it's a not. So you don't really need to write this down because it's kind of obvious, but it's just the opposite. So if you do not of true, it just does the opposite, so false. Okay, and if you did not false, it would be true. Okay, and this is where a nor comes from. If you put a not in front of an or, you get nor. Okay, there's also a NAND where it's not and. We go over that a little bit in CSP before when we were building circuits. But this is actually how computers are based off of. This is how computers do all their logic. It's ones and zeros only. Instead of ones and zeros, in this case, it's true or false, but it's the same thing. It's that dichotomy. But are there any questions on this? Pretty straightforward. Break it down. Some things that are a little bit confusing is the order of operations for this. So I kind of wrote it right here. Not presides over and. Okay? And presides over or. But I wrote this thing right here. Use parentheses to force the order of execution. Don't worry about the order of operation so much. I don't think AP tries to trick you on that. I've never seen it, but maybe they will one day. I don't know. Okay. The next thing, it says short circuit evaluation. Say I had something that was, let's just do the and right here. Let's do the third one. This third one right here, if it was F and T, so false and true, it short circuits it by going, wait, this is false and this is an and, so no matter what, it's going to be false. Let's not even look at this and save some time. That's short circuiting. Okay, now if I flip this, if I flip this to be true and false, it can't short circuit this. Okay, because it's going to true, well, it's an and, I need to check the other one up, false, now it's not short circuited. But you can short circuit a true being first if you did something like this. Okay, true or false, it goes true or, I don't even care if it's false or not, it's definitely going to be true. Okay, again, you're going to learn about this more in the activity. I'm just giving you a sneak preview of what's going on here. Here is a computational thinking exercise. Guess the output, just yell it out when you get it, please. No, you can't go out. Okay, very good. Okay, because is room cleaned is true, but is your homework done? False. So it's an and. They both have to be true. Okay. Sometimes you can get get away with stuff with your parents by going, you have to do your homework and clean your room. It's like, yeah, but my room is really clean. Is there any way I can do it? And then your parents, they just flip the and in their mind to an or, and now you can go out. Right? Does anybody have parents like that? No? Your parents are super strict? Okay, here's an or one now. What about this one? You can go out. Okay, is walking is true. Is car available is false. So it goes true or false. Well, true will short circuit the or false, so you don't have to even do that. So it's just going to be true. Okay. Again, short circuit is not really a big deal. I don't know why AP focuses on it. I've never actually heard of it like outside of this course, but I do have to teach it. So that's why I'm talking about short circuiting. What about this one? Not. You will print. Sorry, you can't go out. Very good. Okay. So that's the gist of this and or stuff.